So after we have this value, we can replace it in this equation, and this is going to become 2x squared times 300 minus 26x squared divided by 42x. Okay, so I could simplify. I don't need to. I could just graph it. You need the calculus, simplify all you want to, but right now, let's just graph. So go to Desmos. I'm going to have 2x squared times 300 minus 26x squared divided by 42x. Okay. If we look here, you can zoom in, you can see a good looking maximum right there. We're trying to maximize our volume. I get 1.961, so x is 1.961. And y is 18.68. Okay, so let's turn these into words that we know. Okay, x is actually x there, which in our picture is there. So that's legit one of my sides. So 2x, because the question is, what is the volume? Okay, well, I could go ahead and find 2x. I could just double x. That wouldn't be too hard. But the output of this graph is my volume. So I don't actually have to know those dimensions. All I have to know is the volume, which I have right there, 18.68. So sometimes understanding what these variables mean in your graph really help because they allow you to do less work. You don't have to find all the dimensions. Only thing the question asked for was what is the volume. Now it also, I'm going to take that back. It did say find the dimensions, so do a little bit more work. So 2x is going to be 1.961 times 2, which is 3.92. I rounded a little bit, that's okay. And then for y, how are we going to find y? Well, we have an equation for y right here. So I'm going to put that in my calculator. Okay. And what I'm going to do is I'm going to store 1.961 for x. That way, all I have to type in is 300 minus 26x squared divided by 42x. And it saves a decent amount of time. I get 2.43. So I have my dimensions, 1.961, 3.92, 2.43, which is kind of my height, and I'm done. And I'm done. Okay. Next problem here. It's a cylinder problem. Now, it says here that they want to make a cylinder with a capacity of 1,250 cubic centimeters. The top and bottom cost 5 cents per square centimeter. The side is 3 cents per square centimeter. So find the dimensions that will minimize the cost and find the cost. So let's look what we got. Can I have a cylinder? And the top and the bottom cost 5 cents per centimeter, and the side is 3 cents. Okay, So I know the volume has to be 1,250. I also know the volume of a cylinder is pi r squared times the height. Now I know my surface area is what's going to cost me money. So surface area is 2 pi r squared, because pi r squared is a circle, and there's two circles, top and bottom, plus 2 pi r, which is the circumference, times the height, which gives us kind of the area of a rectangle, if you want to look at it like that.